All right, welcome. Today we're going to dive into SLB's Intersect Software. If you're a reservoir engineer, this is basically your guide to building a really powerful, predictive digital twin of your asset, right from scratch.
So let's start with the big question, right? The one every reservoir engineer has to tackle. How do you build a digital twin of an entire oil field? I mean, think about it. You've got this incredibly complex system with geology, fluids, all this machinery, and it's all interacting under insane pressure. How do you even begin to model that accurately, let alone predict how it's going to behave and make it run better? The answer, of course, is you've got to create a true digital twin.
And that's exactly where Intersect comes in. Now, I want you to think of it less like a single piece of software and more like a complete digital workshop. It gives you literally everything you need to construct a dynamic operational model, a true digital copy of your asset, from the tiniest pore spaces in the rock all the way up to the facilities on the surface.
So here's how we're going to break this down. This is our roadmap. First, we'll get into the language of Intersect. Then, we'll build our model piece by piece with 3 core modules: the grid, the rock and fluid properties, and finally, the wells and operations. So let's get started.
Okay, first things first, how do you actually, talk to the simulator? The way you do that is with the Intersect Input Format, or IXF for short. And getting a handle on this simple language is the foundation for everything else you're going to do, so let's get comfortable with it. Now, what's so brilliant about this is just how simple it is. The IXF isn't some weird, cryptic, compiled code. It's just a text file, a human-readable text file. You can open it, you can read it, you can edit it directly, and that transparency is so powerful because it means you are always in full control. There are no black boxes anywhere in your model. And just look at this example. It shows you exactly how intuitive the language is. I mean, even if you've never seen this before in your life, you can probably guess what this does, right? It's defining any well that starts with the letter P as a producer. That's it. It's this clean, logical approach that makes building and, frankly, debugging your models so much faster. The entire language really just boils down to these 3 concepts. So in that last example we just saw, the well was the node. That's the object we're defining. The type was the field. That's its property. And that little asterisk was the wildcard that let us apply that rule to all our producer wells in one go. That's really the core logic.
All right, now that we know the language, we can actually start building something. Module 1 is all about defining the grid. The best way to think about this is like we're constructing the 3D container for our entire reservoir model. So, the heart of this module is something called the grid manager, or the grid manager. This is the node where you define the absolute fundamental structure of your model. Its geometry, how you're going to split it up into different regions, and even really complex stuff like faults. It's truly the blueprint for your entire digital world. And this is where you start to see the incredible level of control you have. Inside the grid manager, you're defining the static rock properties for every single cell in your model. You're specifying everything: porosity, directional permeability, you name it. You're building this incredibly detailed picture of the reservoir's architecture before we even think about putting any fluids in it. Okay, so we've built our container. Now it's time to fill it up. Module 2 is all about defining the stuff that goes inside, the dynamic properties of the rock itself, and, of course, the fluids. And this involves 2 key players, the rock manager and the fluid manager. So the rock manager, it handles how the rock interacts with fluids, things like relative permeability that control the flow, or compaction that affects your pore volume over time. And then the fluid manager, that defines the fluids themselves. It doesn't matter if it's a simple black oil model for a quick run or a super complex compositional fluid for a high-fidelity study. This is where you define the actual physics of your system.
So we have our container and we've put the contents inside. The final core module is all about interaction. How do we get fluids out? Or maybe how do we inject new ones in? And that brings us to wells and field operations. This is where the model really comes alive. See, Intersect doesn't just simulate a static box of rock. It simulates the whole dynamic operation. You define your wells, you specify their completions, you set real-world operational roles like pressure limits or production targets, and then you can implement all this complex logic to manage and optimize your field over the entire life of the asset.
And this is where the magic happens. When you bring all 3 pieces together, the grid, the rock and fluid properties, and the field management, you suddenly have this incredibly powerful predictive tool. You can run all sorts of what-if scenarios, test out different development strategies, and do sensitivity analysis to figure out what really drives your asset's performance. So we've walked through all the core components. Let's pull this all together now and map it directly to what your learning path for mastering this software is actually going to look like.
Your training path is going to follow this exact structure. You'll kick things off with the grid MGR, then you'll move to the rock MGR and fluid MGR, and then you'll master wells and field management. And once you have those fundamentals down, that's when you unlock the most powerful capabilities, everything from automated optimization and streamlined simulation to really advanced workflows like tracking CO2 sequestration with the emission MGR. And really, that brings us to the end of our intro. The whole process of learning Intersect is really the process of learning how to build a digital twin. But once it's built, well, that's when the real work, and let's be honest, the real fun begins. The tool is ready, the digital reservoir is built. So what questions are you going to ask it first?